Likelihood, which is nothing but positive class, boys. Positive class plus negative class. That is y into log of y cap plus 1 minus y into log of 1 minus y cap. This is the formula for finding log. Okay. So in the problem statement itself, you have two given values, which is nothing but y and y cap, which is actual and the predicted one. Using that, you are going to find out the remaining things in order to solve and compute the last function. Okay. So first thing is for applying this formula, we need you have y value directly. That's why the next thing is log of y cap is needed. So finding log of y cap. So log base 2, that is ln of y cap, we have to use here. Okay, so first ln of 0.64. The value is minus 0.445 means we can able to take two digits in cylinder. 0.45. Next ln of 0.27. Minus 1.31. Okay, next ln of 0.04.
Minus 3.22.
Minus
3.22.
be louder.
3.22.
3.22. Right? Okay, next ln of 0.02.
Minus 3.91.
Minus 3.91.
1.
Okay, next 0. Ln of 0.81.
Minus 0.21.
Minus 0.21.
21.
0.21. Okay, we got log of y cap. Now 1 minus y cap. So for this, what is the basic thing for us? First, we need to know 1 minus y cap. Am I right or not? We have y and y cap only, right? So before that, 1 minus y cap is needed. So 1 minus
0.6.
0.64.
Minus 0. Minus 0.6.
1 minus 0.64. Listen, before applying ln function, first you have to know what is 1 minus y cap, right? So that is what we are computing now. Okay. So y cap, 1 minus y cap. First value is 0.64. So 1 minus 0.64.
0.36.
0.36. Then 1 minus
0.73.
0.27.
0.73.
0.73. Next
0.96.
1 minus 0.04.
0.96.
0.96. 98.
19.
0.19. Am I right? Right? So now we got 1 minus y cap. Then what is the procedure?
Ln of
Take ln of
0.36.
0.36. Now tell me ln of 0.36
Minus 1.02.
minus
1.02.
1.02. Be louder.
02.
02. Okay. Next thing is ln of 0.73
Minus 0.31.
minus 0.31.
31.
Okay. Next ln of 0.96.
Minus 0.04.
Girls, I need answer. Minus 0.04. Next 0.98. Ln of 0.98. Minus 0.02.
2.
Next
minus 1.6.
ln of 0.19.
Minus 1.6.
Minus
6.
1.36.
26.
26.
ఇప్పుడే పుట్టాలి
66.
66.
Have you got the same answer? Everyone, girl side. Got it? Everyone. So you have y value with its associated log of y cap, and 1 minus y value associated log of y cap. Now apply this formula. Now apply this Make it fast. To apply this formula, you have y value log of y cap computed plus 1 minus y. We need 1 minus y, right? So 1 minus y is equal to 1 minus y. 1 minus 1. First value is 1. So 1 minus 1. Boys. Next 1 minus 0. 1 minus 0. 1. 1 minus 0. 1. 1 minus 1. 0. 1 minus 0. 1. So this is for 1 minus y. So take the first value to apply this formula. Okay? Take the first value. See here, y into log of y. What is the first value of y? Boys, listen. 1 into log of y cap. First value is minus 0.45 minus 0.45
Answer what?
plus
4, 5, 3.
1 minus 5. 1 minus 5 first value is 0. 0 into log of 1 minus 5 cap.
எல்லாத்துக்கும் ஜீரோ தான்
Minus 1.02. So minus 1.02. The value is this becomes 0. So you will be getting
minus 0.
minus 0.45 for first one. Listen here, later you can take. Second y value 0 into log of y cap minus 1.31 plus next value is
1 into
1 minus 5. 1 minus 5 second value 1. So 1 into
minus 0.31.
minus
0.31.
0.31.
31.
So
Minus
this one becomes 0. So you will be getting minus 0.31.
అలాగా
Second page.
1.68.
41. Keep quiet.
6 రా
Third.
సైడ్ ఎప్పుడు
Third value of y is 0.
Minus 6.3.
So 0 into
Answer
minus 3.22 minus 3.22 plus 1 into log of 1 minus y cap 0.04. The value is minus
minus 1.
0.4.
கீழே ஒரு லைன் எழுதணும். 3, 5 எழுதணும்.
First page. Next fourth value. Have you completed fourth one? 1 into minus 3.91 plus
0 into
0 into
minus 0.0.
minus
0.02.
0.02. What is the value?
Minus 3.9.
Minus
3.9.
3.91. So fifth one.
0 into
Fifth one.
0
0. 0 into
minus
log
0.2.
of y cap value is
Minus 0.2.
minus
0.21.
0.21
Yes.
plus
1 into
1 into
minus
log of 1 minus y cap, that is
minus
minus 1.66. So your value is
minus 1.66.
minus 1.66.
66.
Summation equal to
minus 6.37.
summation of these values
Minus 6.37.
minus
6.37.
6.37.
6.37.
Right? This is how, listen, this is how you have to solve this problem. And another thing, in neural network, normally we have to avoid the negative values. In order to avoid the negative values, we are going to apply the negative function to the maximum likelihood. That's why this is called as negative log likelihood function. So in order to minimize the error, in order to avoid the negatives, apply a negative. Normally minus into minus plus, right? So you will be getting a negative value as a result. If you are applying again a negative value, you will be getting positive, right? Minus into minus
Plus.
becomes positive. So that's why we will be applying negative to the log likelihood. So this function is normally called as negative log likelihood function. In order to minimize the negative value and also the error value, we are having this function which is called as negative log likelihood function. Just the same formula. Here you are going to use minus in the precedence. Negative log likelihood function. So the problem may arise based on maximum log likelihood function or maybe negative log likelihood function. Suppose if in the problem apply negative log likelihood function means you have to use this formula. The same formula with the minus. Or else the problem statement is given like computation of log likelihood, maximum log likelihood means you can able to use this formula. Got it? Clear? Just simple, right? Make it fast. Listen now. So we have y and y cap values. You are going to apply this. Based on this, we are going to find out and apply to get the final loss function. Okay. So listen. So for every for in the concept of gradient learning, three things are very important. I told you in the previous class, right? Choosing cost function is very important. The cost function we have seen about many things, right? The most commonly used one is negative log likelihood function. Choosing cost function is important. The next thing is choosing output units, which is also very important in gradient based learning. Third one is choosing the optimizer. So three things are very important. Choosing the best cost function is very important, so that only you can able to get the best results for our neural network W weight into X input plus bias value. So every, if you have Gaussian output distribution, best output unit which is linear units. Okay, linear units. So here we don't have the concept of non-linearity. You know the difference between linearity and non-linearity, right? So here we don't have the concept of non-linearity. So normally outputs are predicted using output. Y cap is nothing but predicted output, right? Predicted output will be computed using the formula weight transpose into input X plus bias value. Normal linear transformation equation. Remember, y equal to Ax plus b, right? Am I right? So instead of using that terminology, in our neural network terminology, weights will be replaced with the slope. So y transpose into X input plus intercept. Intercept is here bias plus b. Okay. So for Gaussian output distribution, best choice is linear units. Okay. So linear output layers. How can we create linear output layers at the end? Okay. It can be hidden layer or output layer. If it is an output layer means next is you are going to find out the mean of conditional distribution. Okay. So that only you will be getting the final output. So mean value. This is the formula for getting mean of the conditional Gaussian distribution. This is mean of actual output and predicted output. L is the number of units in between. Okay. So this is for linear units for Gaussian output distribution. The choice of linear units for Gaussian output distribution. Second one is for Bernoulli output distribution. We have many kind of distribution, right? Normal distribution, Bernoulli distribution, Gaussian distribution. Likewise, we have many things based on the problem. Okay. So Bernoulli output distribution, you are going to, the best choice is sigmoid units. Sigmoid units you know very well. For binary classification problems only, you will be using sigmoid activation function. It lies between 0 to 1 interval. Interval 0 to 1 it will be valid, and here in sigmoid units you will be best using the maximum likelihood approach that we have seen in the previous topic. Okay. So for sigmoid unit, sigmoid output unit will be commonly used in binary classification problem, and the approach which is used here is maximum likelihood approach. In the previous, this is very simple compared to sigmoid units. First is linear units. Linear is very simple. Y equal to Ax plus b. That is what we are doing. Y cap is predicted output. Our output is equal to weight transpose into X input unit plus bias value. You should not forget, this is the key thing, right? Here maximum likelihood approach is the key thing. Okay, for the second one, that is sigmoid output units. Okay, so how can we get Y cap, that is predicted output in the sense? Here predicted output and formula, right? Here Y cap or Y dash we can able to represent in two different formats. You can able to represent Y cap or Y dash. Both are same. Both are what? Actual output, right? Yes or no? Predicted output. So both are predicted output. So sigmoid of Z. Z is nothing but which is equal to 1 divided by 1 plus e power minus z. So Z is equal to again linear equation W transpose into X plus B. So first we will be find out Z value, then apply this to this formula in order to get Y cap or Y dash. Okay. After this, maximum likelihood approach. Okay. To find out positive, that is loss. Clear? Got it? Shall I repeat? Yes.